by we're reflecting triangle ABC across line L. We're labeling our reflected image with prime notation. Okay, our function notation, why don't you guys go ahead and see if you can remember what to do. Okay, is it a lowercase r or a capital R? What goes in the subscript? Okay, what goes in the, I'm doing this transformation to this object spot. Okay, don't peek at mine, but I'm going to write it so that you can check it with mine. Don't peek. Putting you on the honor system. Why don't I have a pen? Okay, there's my pen. Okay, so you should have picked a capital R. Okay, inside the parentheses in the subscript, you should have told me the line of reflection. And then the object that is being transformed. Okay, so just to remind ourselves what we're doing is we are looking for the perpendicular distance for each of our points. And we are finding the same perpendicular distance on the opposite side. Okay? So our two segments that are going to connect our pre-image points with our image points are going to be parallel because they are both perpendicular to our axis of symmetry. Our axis of symmetry is going to be our obviously perpendicular bisector for those segments. Are we all clear? Clear as mud. Okay, here we go. I'm going to zoom out because otherwise this compass is just too huge. Too huge. Okay. All right, so I'm doing metal pointy tip on C. I need to create on line L a segment that I can make a perpendicular bisector for. So it doesn't really matter if I do it like over here. You just want to make sure that you're not going to run yourself off your line. So maybe start with this end because you don't want to do it out here unless you want to do an auxiliary line with a sheet of paper. Okay, so I'm going to start mine here. I'm going to do an arc intersecting my line L. Okay, and then I have to do one on the other side. Why? There we go. Okay, sorry, I don't know why, but I'm having some technical difficulties. Okay, there's my other arc. Okay, so I've now created a segment whose endpoints are equidistant from point C. So I don't want to change the radius of my compass. I want to keep it the same, and I want to find the point on the opposite side that is equidistant from those endpoints. So keep your same radius. Why? Okay. I don't know why this is fighting me today, guys. I'm sorry. Okay, there it is. It doesn't look right, but it is. That is C prime. I don't know why I started with C. What about A? What do I do to find the image of point A if A is on my line of reflection? It's the same. Yeah, if it's on the line of reflection, it maps onto itself. Therefore, A prime is located at point A. That one is nice and easy. Sorry. You know how sometimes you can like refresh or like do something to like your computer's acting up? That helps my board. I don't know why, but it does. All right, now we're going to have to do the process for point B. So I've got my compass. I'm going to create a segment like I did for point C, whose endpoints are equidistant from B. Okay, I don't want to be off my line L over here, so I'm going to start on this end. Arc intersecting L. Oh shoot, that goes right through A. I'm going to do that a little differently. Had it. Okay. I guess it doesn't really matter that it's going through point A. Right? We don't care. Okay. So don't change your radius. Now you want to keep the same radius and find the point that is equidistant from both of your endpoints. I might start screaming. If I start screaming, you guys are going to know why, right? It's because of this board right now. Okay. All right, sorry that this is taking forever. Okay, here is point B prime. So now I can just connect. You're going to have to use your ruler. I don't have to use a ruler because I have a straight little segment thingy. Sorry. You have to use a ruler and connect your points. So, what do we see? We have congruent segments. All of my sides of my figure should be congruent to their corresponding sides. Okay? My image should be congruent to my pre-image. Okay. Okay, so a translation is a transformation in which a figure is shifted horizontally and or vertically without any rotation. Okay? So we talked about this when we talked about translation symmetry at the beginning of the unit with sometimes the tessellations rotated, but the ones that you didn't rotate had the translational symmetry. Okay, so they can't spin at all. A translation requires a distance and a direction. When you get into your upper level classes, they will call this distance a magnitude. Okay. Anyone here been in physics where they talk about vectors that have magnitude and direction? Seeing some nods, thank you. Stay tuned, it's coming. The distance and direction can be given by a vector, hence the magnitude and direction. Okay, so we are going to translate segment PR along the vector that goes from P to X. So do you see, when I do a ray, let's say I wanted to do like the ray that goes from P through R, that would be ray PR with an arrow that has two little flappers on it. Everybody see that? This vector symbol has a barb. Okay, it's not an arrow, it just has like that barb. You guys see the difference between vector and arrow? Okay. Cool. All right, so our function notation is going to be big old capital T. Okay, in the subscript, we have to do the directions for performing the translation. So we have to give the vector. So we're going to go along vector px. So with a barb, not an arrow. And then last but not least, the figure that is being transformed. So it will happen to segment PR. Okay. So this is my vector px. Okay. It has a length and it has a direction. That said, I can move it around anywhere, right? So what I'm going to end up doing is also moving R along the same direction and same magnitude, so same vector. You see what's going to happen? All right, but we have to be able to copy this vector with a compass and a straight edge. So this is where it gets exciting. All right, so you need your compass. You're like, we already have ours. Get with the program, lady. So we are going to copy that distance. I'm going to copy my distance from P to X. I want orange. Okay. I'm going to copy it here. So I want point R to move that same distance in that same direction. Okay, now I don't exactly know where on that arc I'm going to put R. Am I going to put it here? Am I going to put it here? We don't know. We need another measurement. You see that I have another length to copy. I can also copy the distance from P to R. Okay? So if I go to X and I copy that distance, that will tell me the location of R prime. Okay, so that's the plan. So P prime landed on X. That was in our directions, because that's what our vector said to do. Copied the distance from P to X. Now I'm going to copy the distance from P to R. I'm going to change colors. I'm going to be blue now. Okay, you didn't need it. Okay, copying that distance here. Voila. There is the location of R prime. Okay, using your straight edge, connect your points. Okay, that's it. Easy peasy. So here's the test. Is it the same distance, the same direction away? Yeah. Voila. Voila. All right, what if instead of a segment, we had this whole crazy triangle? This time we're going along PZ. So here is my vector. It's going from P, oops, I wanted the dashed. I kind of like that. It's going from P to Z. So I'm going to slide that whole triangle, that distance in that direction. Let's do the function notation. We're going to translate along vector PZ with the barb, and we're doing this to triangle PRQ. Okay, so first we get to copy the distance from P to Z. This is my point P prime. Copy the distance from P to Z. Okay, I'm now going to have R and Q both go that same distance in the same direction. So my R prime is going to be somewhere over here. I don't really know where. And my Q prime, somewhere over here. Don't really know where. So we don't know where on those arcs R prime and Q prime will be. The only other measurement we have to be able to locate them is how far are they away, how far are the pre-image R and pre-image Q away from point P. So those distances are what we have to copy. So I'm using my compass to copy the distance from P to R. Copying that distance from point P prime and seeing where that intersects with my vector length. Okay, that is my location of R prime. Okay, now I need to measure the distance with my compass from P to Q. So metal tip back on P, measuring P to Q. Copying the distance from P to Q, starting at P prime. And that is the location of Q prime. That's pretty good. All right, connect your image points with your straight edge. Whoa, that's not straight. Wow. Oops. The sound effects really do help. Okay, there is one point that we need to make before we go any further. We've mentioned that this should be the same distance, the same direction. And, whoops, this one's a little off. Sorry, I messed that one up a little bit. But what I also want to show you is that if we connect R and R prime and Q prime, what do you notice about, well, see, I got this one in the wrong spot. So where they actually intersected on my picture, I just put my dot in the wrong spot. My arcs intersected in the right spot, but I put my point crooked. I should have put my point right there. Do you guys see the difference between here and here? Okay. How can you tell that that's right and this where I put it is wrong? Can you see it with my me being in the way. Wrong, right, wrong, right. How can we tell that that's right? Yeah, it's straight. How can we tell it's straight? Because what are these to each other? They should be parallel. So if you've done it correctly, all of your vectors should be parallel for a translation. Okay, when we reflect, the segments connecting pre-image to image are parallel, but they're not the same length. These are parallel and the same length. Cool? Okay. Okay, so we get to use this cute little figure. Okay. We have to name the image of segment DR after it is rotated 90 degrees counterclockwise about point P. Well, how do we figure out what 90 degrees is? We kind of have to use some of our rotational symmetry stuff. You guys see that if I look at this little triangle and like think about how many positions it could have, there's 1, 2, 3, 4, 5, 6, 7, 8. So if you think about the rotational symmetry for this geometric object, what is its order? 8. Okay, so what would be the angle of rotation? So we take our complete turn, which is 360 degrees, divide it by the order, thank you, it's 45 degrees. Okay, so can we agree that each one of these little micro turns is going to be 45? Okay. So how many 45-degree turns is 90 degrees? 2. So if I do 2 of them, that's a 90-degree turn. Okay? Everybody happy? Okay. Now I'm going to erase all this stuff because it's a lot on there. So we were talking about segment DR, and we are rotating 90 degrees counterclockwise. So is that the positive or negative direction? Positive. Okay, so if we think about D rotating 90 degrees, D is going to map to, okay, and then R is going to map to G. So my question for you is, can I write this segment as GI? I want you to think about it. I had an early confident no. So are GI and IG the same segment? Okay, so that would be like, okay, we could write it that way. It's the same segment. However, we said that D should land on I and R should land on G. So can I write it in this order? No, because the order tells me the corresponding parts of the image and pre-image. Okay? The order matters. So I have to say GI. Wait, IG. Oh my gosh. Which one is it? IG? Okay. Okay, not GI. All right. Whew. Okay, now we have to name the image of BI. If it is rotated 180 degrees clockwise about point P. So how many 45-degree turns is that? 4. Okay, so clockwise, that's this way. We're going to go this way. So let's start with B because that's the first letter. So 1, 2, 3, 4. B maps to R. I maps to, 1, 2, 3, 4. Maps to E. 3. Okay. All right, I want you to try C. So we're doing AE. Where is it? AE. We're going in the positive direction. How many turns? 6. Okay, so 1, 2, 3, 4, 5, 6. So A goes to B. All right, and then E is going to go to 1, 2, 3, 4, 5, 6. M. Okay, if you did not want to go around the whole thing, instead of going 270 degrees counterclockwise, how could you rotate A to get to B the short way? Yes. Okay, and then you could do the same for E. And that would put you on M. Now they're just all circled. Okay, so if you have a 270-degree turn counterclockwise, that is equivalent to, correct. Okay, when you get into trig, pre-calc, you're going to do this thing called coterminal angles. That's angles that end in the same spot. That's what it's doing. We're finding other names for the same angle, like to get the ray to end in the same spot. Okay. All right. What about if we take the segment RE and we reflect it in the line MD? That's my line of reflection. So perpendicular distance. Do you see that oh, those are not right. You see that I end up, my R lands on G if I do perpendicular distance? Everybody see it? So R goes to G. What about the E? Goes to I. Good. In that order. Okay, find the pre-image of IG that was reflected in GA. So change your line of reflection. So we're finding the pre-image. So point I had to come from where? Point D. And G just came from itself, G, because it's on the line of reflection. Okay, now we have to name the image of GD as it is translated along GM. Okay, so let's do a different color. Here's GD, and my vector is going from G to M. So I have to also translate D along that vector. And if I do that, where does D land? You see that it goes to A? So G goes to M, D goes to A. MA. Okay, name the image of segment PE if it is rotated negative 90 degrees about point E. Go ahead and think about it while I get this cleaned up. It's kind of PE. Okay, negative 90 is clockwise or counterclockwise? Clockwise. So 90 degrees, 245 degrees turns in the direction of the clock. So if P is at the center of rotation, it's going to map onto itself, okay? But what about E? Where does E go? M. So we'll call that PM. Segment PM. Okay, name the image of point A if it is reflected in PE. The line that goes forever. Point R. Okay, name the image of triangle pig that was reflected in line BR. So triangle pig is this guy. The line of reflection is BR. Okay, so where does P map to? Itself. So it's going to be triangle P something. Where does I map? M. Where does G map? A. Goes right here. Just make sure that you get them in the right order. Okay, you can't just say Pam, right? Or map. Okay.